Hello everyone. In this brief video, I want to introduce circular motion. As you know that Newton's law of motion primarily related to straight line motion, uniform circular motion, motion in circle with constant speed, rotation angle. This is delta theta, angle through which an object rotates, like in this disk, in this circle. There is making an angle delta theta from here, this point to this. This is angular displacement. When you are consider a circle having radius r, small r, and point A and B on this circle, and some object displaced from point A to point B, then this displacement is known as angular displacement, and this arc ds having uh, on the this arc is in other words displacement in terms of A to B. Arc length is the distance around part of circle, and this angle is equal to arc upon radius, and its units are in revolution. One circle is equal to one revolution. In degrees, one circle will equal to 360 degree, and in radians, one circle is equal to 2 pi. Arc length formula must be used radians and angle unit. As you know, 2 pi is equal to 360 degree is equal to 1 revolution. Now, angular velocity. Angular velocity is how fast an object rotates. Mathematically, omega is equal to delta theta upon delta t, and its units are radian per second. When you compare it with linear velocity, v is equal to delta s upon delta t, distance upon time simply, then delta theta is equal to delta plus s upon r, which implies delta s is equal to r delta theta. After putting the value of delta s instead here, then velocity will equal to r delta theta upon delta t. This delta theta upon delta t is angular velocity. Therefore, linear velocity is equal to r times angular velocity. R is the radius of circle. Like as this. This is the angular rotation. Now, I'm giving you one situation. Make a hypothesis about what will happen, which path will an object most closely follow when the centripetal force is removed. As you know, centripetal force is toward the center. When this force has negligible value, have zero value, then which path A, path B, and path C, that object will follow. On the behalf of previous knowledge, you can find that. Now, this is circle at different point, at point O, when you are taking time t naught is the initial point, p is the after time t. Okay, these are two different points having velocity v here perpendicular to that point, making an angle theta at the origin. Then object moves in circular path at time t naught. It is at point O with a velocity tangent to the circle. At time t, it is at point P with a velocity tangent to the circle. The radius has moved through angle theta. Now, these two are isosceles triangles. This theta is equal to this angle, and this velocity at time t naught and this velocity at time t. This is the displacement delta v, which is equivalent to this one. So having r radius and this v times delta t is displacement from O to P. Draw the two velocity vectors so that they have the same tails. The vector connecting the heads is delta v. Draw the triangle made by the change in position and you get the triangle in B. Now, since the triangles have the same angles, so they are isosceles, they are similar, and you know that delta V upon V will equal to V times delta T upon R because they are isosceles. Delta V upon V is equal to delta V delta T upon R. Both are equal. Hence, delta V upon delta T. Put delta T here and V here. It will cross multiply. Delta V upon delta T is equal to V square upon R. That is centripetal acceleration. AC abbreviated is equal to V square upon R. Put the value of V, linear velocity. We have calculated in previous slide. V is equal to R omega. Then it will comes R square omega square upon R cancel, then remaining R and omega square. This is the expression for centripetal acceleration. Thanks for your attention.